Assalamu alaikum students. Today we start new chapter sets, function and graphs, groups. First there is an introduction about sets. A set is generally described as well-defined collection of distinct objects. By well-defined collection is meant a collection which is such that given any object we may be able to decide whether the object belongs to the collection or not. By distinct object we mean object no two of which are identical, means same. The object in a set are called its member or element. Capital letter A, B, C, X, Y are generally used as name of sets, and small letters are used as member of sets. There are three different ways of describing a set. First is descriptive method. A set may be described in words. For instance, the set of all vowels of the English alphabet. We represent a set of vowels as the vowel of the English alphabet. The tabular method. A set may be described by listing its element within brackets. If A is a set mentioned above, vowel of the English alphabet, we written in tabular form it like this: A, E, I, O, U. But in descriptive method we only write vowel of English alphabets. Third form is set builder method. It is sometimes more convenient or useful to employ the method. Set builder notation in specify set. This is done by using a symbol or letter for an arbitrary member of the set, starting the property common to all the members. Same set in both cases we discuss. A is equal to X. Straight line shows such that X is a vowel of the English alphabet. In this set builder notation we write like that. This is read as a set of all X such that X is a vowel of the English alphabet. The symbol used for the membership of a set is like E means belongs to. A belongs to A means A is an element of A, or A belongs to A. C not belongs to. If we cut this sign, it means C not in this set, does not belong to the set A. Here are some examples of set we already discussed in the last chapter. N represents set of natural numbers. W represent whole numbers. Z represent integers, plus minus 1, plus minus 2, and Z dash represent negative integers. Next, O the set of all odd integers. Odd means those numbers not divisible by 2. E set of all even integers. Q set of all rational numbers. We represent by set builder notation. X such that x is equal to p over q, where p and q belongs to z. Z means integer and q not equal to 0. Always denominator of a fraction never equal to 0, because if denominator is 0 it becomes undefined number. Q dash set of all irrational numbers. We discussed both these sets in first chapter. Rational numbers are in like natural numbers, whole numbers, integers, and also in decimal, terminating decimal, and recurring, and other than these, like set of irrational number, it contains only non-recurring, non-terminating, and prime numbers, square root of prime numbers are also in irrational numbers, and both these numbers union become real number. Next is a definition of equal sets. Two sets A and B are equal if and only if they have same elements. Like there is example 1 2 3 2 1 3. Order not depends, but the elements are same. Note, if A and B are equal if and only if they have same element, means if A and B they have the same element, and if A and B have the same element then A is equal to B. The phrase if and only if is shortly written as if IFF. In exercise 1.3 question number 4 we used this phrase. Equivalent sets. This is equal. No, it is equivalent. If the element of two sets A and B can be paired in such a way that each element of A is paired with one and only one element of B. For example, if the quantities of the two sets are same, then these are equivalent sets. Like these two sets, it contains 3 boys and the next set contains 3 girls. Same quantities, it means these sets are equivalent. Consider the set n natural numbers, O odd numbers. There is 1 correspondence between them, because for every single number in natural number there is a number in odd number. Like that, for 1 there is 1, for 2 there is 3, for 3 there is 5. So these two sets are equivalent sets. This symbol is used for equivalent sets. Next is order of a set. There is no restriction on number of members of a set. A set may have 0 element, 1 element, 2 element, 3 element. A set with 0 element is called null set, and a set with 1 element is called singleton set. There is the same equation, x squared plus 1 is equal to 0. If we solve this equation, we get a complex number which is not a real number. Also the empty set if we solve it for the real number. Clearly the set 0 is a singleton set because it contains one element. Next is finite and infinite. If a set is equivalent to the set 1, 2, 3 up to n for some fixed natural number n, then the set is said to be finite, otherwise infinite. Sets of number n, z mentioned earlier are infinite set because there is no endpoint for these two sets. This set also contains a lost number, so it is infinite set, but the set contains no lost number, it means it is infinite. Next is subset. If every element of a set A is an element of set B, symbolically we written as A subset of B. In such a case, we say B is a superset of A because B is greater than A. This is written as A is a subset of B or B is a superset of A. The above definition may also be stated as follows. A is a subset of B if every element of A also belongs to B. X belongs to A implies X belongs to B means every element of A belongs to B. Next is two definition, proper subset and improper subset. If A is subset of B and B contains at least one element which is not an element of A, then A is called proper subset of B. In such a case, we write A is a subset of B. It means A is not equal to B, some element or missing. Improper subset. If A is a subset of B and also equal, then we say that A is an improper subset. It means for improper subset, both sets are equal. In this example, we clear these definitions. A contains ABC, B contains also ABC, and C contains ABCD. It means A is a subset of C and A is a proper subset of C, and A or B are equal. These two sets are improper subset, and B is also a proper subset of C. I think you understand. When we do not want to distinction between proper and improper subset, we may use the symbol for the relationship. It is easy to see that, and this is very important note, n is a subset of integer because every natural number is also integer and all integers also rational numbers and all rational numbers are real numbers. And this sequence you must learn. N is a subset of integer, integer is a subset of rational, and rational is a subset of real. Next is a statement. The empty is a subset of every set because it contains no element. Next is power set. A set may contain element which are sets themselves. For example, if C is equal to set of classes of a certain school, then element of C are sets themselves because each class is a set of student. An important set of set is a power set of a given set. We try to understand this definition by example. The power set of a set S denoted by P of S, power set of S. All possible subset of the set S. We have an example. A set A contains two elements A and B. Then power set of A, we start from empty set, then singleton set A and B, and then double element, and this is the loss set because it contains only two elements, and these are its power set, and it contains four elements. Empty set A and B are proper, and the loss set is AB is equal to A, therefore it is improper subset. Next example, we contain three elements 1 2 3. We start with empty always, then singleton set 1 2 3. Next is double pairing 1 2 1 3, and then 2 3, all pairing. And next for three elements only one set, and loss set is always improper because it is equal to the given set, and the remainings are proper subset. Now example 5 and homework for you, try to solve it. Example number 6 contain a single element, singleton set. Its power set is empty and same set. Example 7, empty set. Its power set is also empty, but E contains no element, but its power set contain one element which is equal to E. And this is also a note: the power set of the empty set is not empty. Important for objective. NS means noted the number of element of a set S. NBS means note the number of element of power set. And this table shows some element. If a set contains 0 element, like example number 7, then its power set contain 2 raised to power 0 1. If an element contain one element, 2 raised to power 1 is equal to 2. If an set contains two element, 2 raised to power 2 is equal to 4, and so on. And we develop a formula. If an set contains m element, then its power set contains 2 raised to power m. Next is universal set. When we are studying any branch of mathematics, the set with which we have to deal are generally subset of bigger set. Such a set is called universal set. In any question, if we have a universal set, it contains all element of the given sets. It is also called universe of discourse. Next we have an exercise. Okay students, in next lecture we solve this, but try to understand the previous things. Try to solve the questions, and in next lecture we will